Hi! In this video we'll be solving a system of equations, and in particular we'll be looking at linear equations. So there is a standard approach for it, and that is the approach that we will use in this video, and it's called Gaussian elimination. And we will somehow manipulate these equations such that we want to end up with x is something in the first equation, y equals something for the second equation, and z equals something for the third one. So we can do this by multiplying these equations by some numbers, adding them up, subtracting them, etc. And this is the form that we want to end up with. And because writing down these equations in each step would take a lot of work, we came up with a shorter notation for this, so we can use some matrix to denote exactly these equations. So in the first row, we will have the first equation, and the first column denotes the number for x. So we have 2 times x, then we get, so there's 1 times y, minus 1 times z, and then sort of separately, we have an augmented matrix. We have this 8 here. And then in the second row, we have minus 3, minus 1, 2, and minus 11 here, and then minus 2, 1, 2, minus 1. So this matrix contains exactly the information that is in this system of equations. So we'll now further calculate using this matrix instead of these equations. To give you one example of what happens if we do some calculation here and what that means for the equations, so let's say we divide this first row by 2. Then we end up with the matrix. So 1, 1/2, minus 1/2, and 4. And the other 2 rows are as before. And the final one as well. So this matrix corresponds to dividing this first equation by 2. So if we divide this equation by 2, we get x plus 1/2 y minus 1/2 z is equal to 4. So each of these steps we take here also correspond to some steps with the original equations. So our goal is to end up with something of this form, which means that we will have, in the first row, we will need a 1 here, and zeros in these 2 places, because we have no x and y in that expression, so we want zeros here. In the second row, we want a 1 in the middle spot, and zeros everywhere else. And in the final one, we want a 1 in the last column, and then these zeros. So how we are going to do that is that we will sweep the matrix. And what does that mean? That means that we will use first set 1, the top left item correctly, which we already did. It's a 1. Nice. And then we can get rid of these other 2. We will change them into zeros. So we will sweep down and make all of the other entries in the first column 0. So how do we do that? Well, we add the first row 3 times to the second row, and we add the first row 2 times to the final one. Okay, so let's continue here with our result from this computation. So the first row is unchanged, so 1, 1/2, minus 1/2, and here we had 4. Then we do 3 times this one, we add to this one. So the first one becomes a 0, which was exactly the goal. So then we get 3 times 1/2, so 3/2 minus this 1 here. So we get 1/2. Let me see if I'm still correct. Yes, and then we do 3 times this minus 1/2, and then plus 2. So there again, we get 1/2. And then in the final one, we also always have this last column that we take care of. So 4 times 3 is 12, minus 11 is 1. And then we did the same thing for the last row, but then with times 2. So the first element becomes a 0. Then we have 2 times 1/2 is 1, plus 1 is 2. Then we have 2 times minus 1/2 is minus 1. So here we get a 1. And then we get 2 times 4 is 8, minus 1 is 7. All right, so now we continue on to the second row. So we have the first one. Now we want to make this into a 1. So we simply multiply this row by 2. So all of the other things remain unchanged. So let me write them quickly. The second row, we do times 2. This, of course, stays a 0. We get a 1 here, a 1 here, and a 2 here. And the final row is unchanged. All right, now we can sweep down again from this one. So if we sweep down, then we do minus 2 times this one, we add to this one. Okay, so let's see the first row again, unchanged. The second row, unchanged. The third row, well, there was already a 0 here, so this 0 does not change, which is nice. And then we get a 0 here. Then we get minus 2 times 1, so minus 1 in total because we add this plus 1 here. Then we have minus 2 times 2 is minus 4 plus 7, so we have 3 here. All right, so now only the last row still has something that is not a 1 on this diagonal. So we need to change this into a 1, and to make my life a bit easier, let's just remove this minus and put a minus in front of this 3. So we just multiplied the last row by minus 1. Okay, so now this bottom triangle, that's already in the correct form. But outside of this, we still want all zeros. So now we sweep again, but now we start at this value here, and we sweep upwards. So we want to subtract this row once from the one on top, and then similarly for the top one, we add it 1/2 times to get rid of this minus 1/2. All right, so let's see what will be our next step. So here we have all zeros, so these first 2 elements of the top row do not change. Then we get a 0 because we swept with this last one. And then here we have 3 times 1/2, so 3 halves, and then plus 4. So if I'm not mistaken, we have 5 halves here. Then we look at the second row. So these first 2 elements remain unchanged. Then we do 1 minus 1 is 0. And finally here we have 3 times minus 1. So 2 plus 3 is 5. And, well, the final row, we were already happy with that one. So there's just one element that still needs to be adjusted, namely this one here. So what we will do is we'll again use this middle one. So we will subtract 1/2 times the middle row of the top row. So then we find a 1, a 0, a 0. And here we get 5 times minus 1/2. plus 5/2. So there we have a 0 again. Coincidentally, we don't necessarily need zeros on this side. Then we have 0, 1, 0, 5, and 0, 0, 1, minus 3. All right, so now we are in this form that we had here, because if we write these things as equations again, so the first row, it tells us 1 times x plus 0 times y plus 0 times z is equal to 0. And the second one tells us that y is equal to 5, and the final one is z is equal to minus 3. So now we have found a solution to our system of equations. So it's very easy to make mistakes in one of these steps. So just to be sure, it's always good to check whether these actually form a solution to these equations. So let's just check the first equation. So we have 2 times x, which was 0, so 0 plus y is 5 minus 3, so 5 plus 3 is indeed 8. Okay, so at least the first one is correct. I think you can check by yourself that the other two are also correct. So that will be the end of the video then. We have seen how to solve these equations using a standard approach, and this will always work if you have a system of this form. Good luck.